I want us to continue seeing the effect of or the relationship between ionic product, solvated product, and precipitation. I'm going to end that with some more 2 questions. There is a question here. It says, when ammonia solution is added to, which solution can I use here? When ammonia solution is added to when ammonia solution is added to which solution? To barium chloride solution. Barium chloride gives us a very low concentration of, its solvated product doesn't easily exceed, its ionic product doesn't easily exceed its ionic product. Its ionic product doesn't easily exceed with its solvated product with ammonia solution. I should look for another example. So when you add ammonia solution to copper 2, this one will lead to complex ion formation also. It may not work for me. Which solution can I think of? Can think of manganese chloride. Manganese 2 chloride. When ammonia solution is added to manganese 2 chloride, a dirty white precipitate is formed. You may not be aware of this, but you need to know it, that manganese 2 ions form white precipitates with sodium hydroxide and ammonia solution, which white precipitates later turn dirty white. We shall see that explanation when we further our knowledge with transition metal chemistry of manganese in organic. That's when we shall see that detail. So when you add ammonia solution to manganese 2 chloride, a dirty white precipitate is formed. That's the first part of my question. Or you can call it a white precipitate that turns brown on standing is formed. However, let me continue with my question. However, in the presence of ammonium chloride, no precipitate is formed. No precipitate is formed. Explain. Good questions that really test your understanding, and they usually carry very many marks, 5, minimum 4, up to 6 marks. What do you have to say? Why is it that when you add ammonia solution to manganese 2 chloride, a dirty white precipitate is formed? If I wanted to make this question longer, I would say a dirty white precipitate that turns brown on standing, but that will be for another time. So what will you say? You begin with telling us something about ammonia. You say ammonia is a weak base, partially ionizing to form ammonium ions and the hydroxide ions. I prefer calling them hydroxide ions than hydroxyl ions. Write the equation. But don't write as poor as I am doing. So that's the equation. Now it is these ions that are going to react with manganese 2 ions, form the dirty white precipitate we are talking of. And why is the precipitate ably formed here in this case? Is because the concentration of hydroxyl ions, although ammonia is a weak base, the concentration of hydroxyl ions it gives us is high enough for the ionic product of manganese 2 hydroxide, which we are forming here. It is the ionic product of the sparing the soluble electrolyte that exceeds its solubility product. So you bring in that concept. The concentration of hydroxide ions is high enough for the ionic product of manganese 2 hydroxide to exceed its solubility product. Therefore, manganese 2 ions react with hydroxide ions to form sparingly soluble or insoluble manganese 2 hydroxide. Write the equation. Are we together up to that point?
Yes, teacher.
So you say, therefore, manganese 2 hydroxide is precipitated. However, let's go to the second case, which says that in the presence of ammonium chloride, no precipitation occurs. Now here, your brain must think, you see this is ammonia solution, this is ammonium chloride. What do you realize? There is common ion effect there, which is as a result of ionization of the strong electrolyte ammonium chloride. So here, what do you have? You have ammonium chloride, a strong electrolyte, and very soluble, ionizing to give us ammonium ions and chloride ions. So why is there no precipitation occurring here? I want you to see the relationship be here. I wouldn't write this equation again, but let me write it again. This gives me ammonium ions and hydroxyl ions. So talk of this ammonium chloride being a strong electrolyte, completely ionizing to give ammonium ions and chloride ions. And recall what we looked at in a buffer solution, where we talked about separation of ionization. So here, the high concentration of ammonium ions from the strong electrolyte ammonium chloride suppress, I would use the word suffocate, but it will not work here. They suppress the ionization of ammonia. When the ionization of ammonia is suppressed, that implies that we are going to have very few hydroxyl ions, which may not be able to react with, which may not give us a good high enough concentration to react with manganese 2 ions to precipitate manganese 2 hydroxide. Are you getting the concept?
Yes, teacher.
So the ammonium chloride being a strong electrolyte completely ionizes to form ammonium ions and chloride ions. The ammonium ions from the salt suppress, that's the key point. The high concentration of ammonium ions from the strong electrolyte suppress the ionization of ammonia, reducing the hydroxide ion concentration in a solution. Therefore, ionic product of manganese 2 ions cannot exceed its solubility product. Hence, precipitation does not occur in that case. Are we together? Okay.
Yes, teacher.
Even if I don't write that, you've got the concept. Finally, I look at my final question that involves application of the same idea. This is also another good question. It says, when hydrogen sulfide is bubbled through when hydrogen sulfide is bubbled through a solution, which solution can we use here? A solution of, let's call it a solution of magnesium nitrate. Is it magnesium nitrate? Okay, let me call it manganese 2 nitrate. When hydrogen sulfide is bubbled through a solution of manganese 2 nitrate, in the presence of dilute hydrochloric acid, no observation occurs. But in the presence of ammonia, a pink precipitate is formed. Explain. When hydrogen sulfide is bubbled through a solution of manganese 2 nitrate in the presence of dilute hydrochloric acid, no observation occurs. But in the presence of ammonia solution, a pink precipitate is formed. What is that pink precipitate they are talking about? That pink precipitate is manganese 2 sulfide. It is what would be formed between manganese 2 nitrate and hydrogen sulfide. Now they are saying that that pink precipitate cannot be formed in case hydrochloric acid is present. Okay. So you see that there is a relationship between hydrochloric acid and hydrogen sulfide. That could be the reason. This is a stronger base. I mean a stronger acid. Hydrochloric acid is a stronger acid or a strong electrolyte. The solution of hydrogen sulfide, however much it is a gas, in solution, it is a weak electrolyte. So the hydrochloric acid, the high concentration of hydrogen ions from hydrochloric acid are going to suppress the ionization of the weak hydrogen sulfide. Hence, the hydrogen sulfide will not give us a high enough concentration of sulfide ions to react with manganese ions to precipitate manganese 2 sulfide. That's the concept there. In presence of ammonia, why is the pink precipitate formed? We're going to see that. Let's look at the first part of the question. This is what we have. The solution of hydrogen sulfide in water, or you may write a gas, and then you say it ionizes in water to give us which ions? It gives us hydrogen ions. And what else? And sulfide ions. Is the equation balancing? Is the equation balancing? These are 3, these are 4. The sulfur is 1. The charge here is, so shall we need something like a 2 here? That makes the hydrogen 6, a 2 here. Hydrogens are 6, these are also 6. These hydrogen, the sulfurs are 2, we need a 2 here also. And the 2 here, I think this will not balance the equation. What can we do to balance this equation? We can have
a 2 on water.
Have a 2 here. That is 6. Then a 2 here. That is also 6 hydrogens and 2 oxygens. I think it balances that way.
Yes, teacher.
Yeah. So that's the equation we do have. Then in the presence of hydrochloric acid, what happens? This is a strong electrolyte. It will completely ionize to give us hydrogen ions and chloride ions. So this is where our concept will be. So what shall we say? We shall say hydrogen sulfide is a weak electrolyte in solution. Don't just say it's a weak electrolyte, because it is a gas, you must add the word in solution. Partial ionizing to give us hydrogen ions and very few sulfide ions. Hydrochloric acid is a strong electrolyte, completely ionizing to give us very many hydrogen ions and chloride ions. The hydrogen ions from the high concentration of hydrogen ions from hydrochloric acid suppresses the ionization of hydrogen sulfide, which in turn gives us very few sulfide ions. Very few sulfide ions, such that the concentration of manganese 2 sulfide, such that that concentration of sulfide ions that is very low is not enough for the solubility product or for the ionic product of manganese 2 sulfide to exceed its solubility product. Hence, it cannot be precipitated. Are you getting the idea? Because of the separation of ionization of hydrogen sulfide, chetwagala are these sulfides, yes, which are going to react with the manganese ions to give us the pink precipitate, manganese 2 sulfide. So since hydrogen sulfide is a barrier here, I mean hydrogen chloride or hydrochloric acid is a barrier to the ionization of hydrogen sulfide due to its hydrogen ions giving us an high enough concentration. The high concentration of hydrogen ions from it suppress the ionization of hydrogen sulfide, which in turn gives a very low concentration of sulfide ions after separation of its ionization. So that very low concentration of sulfide ions cannot give us a high enough sulfide ion concentration for the solubility for the ionic product of manganese sulfide to exceed its solubility product. Hence, precipitation of manganese sulfide cannot occur. However, what happens if the same reaction is carried out, but in that case, in the presence of ammonia solution? This is what happens. In the presence of ammonia solution, this is what happens. The moment you introduce ammonia, actually it's not ammonia solution, it's ammonium chloride. In the presence of ammonium chloride, which is a strong electrolyte, complete ionizing to give us a high concentration of ammonium ions. And is it ammonium chloride? I think I'm answering the first question instead. This is ammonia solution. That's what the question is suggesting. In the presence of ammonia solution, this is our question. When hydrogen sulfide is evaporated to solution of manganese nitrate in presence of dihydrochloric acid, no observation occurs. But in presence of ammonia solution, a pink precipitate is formed. So in presence of ammonia solution, this is what happens. However much it is also weak base, giving us ammonium ions and hydroxyl ions or hydroxide ions. There is a reaction between these two here. So the hydroxide ions react with hydrogen ions to give us water. Can we balance this equation? Yes, we can, by putting a 2 here. Those are 4 hydrogens, which are the same as this side and 2 oxygens. So in that case, this is what happens. In the presence of ammonia solution, the hydroxide ions formed from the partial ionization of the weak ammonia solution in water. Those hydroxide ions react with the hydrogen ions from ionization of hydrogen sulfide to form water. That reduces the concentration of hydrogen ions. Now, hydrogen sulfide will not be happy. This man here won't be happy. You are taking away its hydrogen ions. So it will ionize such that the hydrogen ions are being replaced to restore equilibrium. So as it is replacing the hydrogen ions, it is unknowingly giving us sulfide ions, which are now going to react with manganese 2 ions to precipitate manganese 2 sulfide. Are you getting me?
Yes, teacher.
So we shall say in presence of ammonia solution, which is a weak base, partial ionizing to give us hydroxide ions. The hydroxide ions react with hydrogen ions from the ionization of hydrogen sulfide to form water. That reduces the concentration of hydrogen ions in the solution. To restore the equilibrium, hydrogen sulfide ionizes. And as it ionizes, it produces a high enough concentration of sulfide ions for the ionic product of manganese 2 sulfide to exceed its solubility product. Hence, manganese 2 sulfide is precipitated. That brings us to the end of the effect of the the 3 factors that affect solubility or sparingly soluble salts, and also the relationship between ionic product, solubility product, and precipitation. I want to end this lesson with application of KSP. Solubility product is applied in each of the following. It is applied in salting out soap during saponification. It is applied in purification of common salt, which is sodium chloride. It is applied in precipitation of hydroxides and sulfides. That's what we have just seen. It's applied in precipitation of hydroxides. In the last example, I've been seeing precipitation of sulfides. So it's applied in precipitation of sulfides. It is also applied in precipitation of chlorides. In our next episodes, we shall see seeing calculations involving solubility product. Subscribe to our YouTube channel for more of these. And in our next lesson, we shall be completing anything relating to solubility product, and I'll now be looking at chemical kinetics next. Thank you for attending this lesson.